Alright, we're graphing two variable inequalities today, basically linear inequalities, alright? And so here's some basic steps I'd encourage you to think through and review with me. Rearrange the equation in a slope-intercept form if you need to, okay, if it's not already a nice y equals mx plus b. Graph the line just like you normally would. Now if the equation contains a less than or greater than with no equals in there, then you want to make it a dashed line, okay, and the line itself is not included in the solution set. Now here's one way to tell which side of the graph do I shade, because this is where a lot of struggles pop up. I like to plug a coordinate in, and if I can, I use 0, 0 just because it's easy. Okay, sometimes you can't because the graph goes right through 0, 0, but plug it in and see if it's true. If the coordinate that you chose made a true inequality, then you shade the side of the graph that you got that coordinate from. Okay, if the coordinate makes a false statement, then you're going to shade the opposite side of the graph. Okay, and as you get more comfortable with these, you probably don't need to do that, but it's a good thing to just go test a point. As an alternative, if the inequality is less than or less than equal to, you're going to shade below the graph if you feel comfortable what that below means. If it's greater or greater than equal to, you're going to shade above the graph. Okay, let's go look at some examples. So, which graph represents the inequality y is less than negative 4x plus 2. Now all these graphs look the same, okay, the lines anyway, so they're not tricking me there. So, a couple things to look for. Notice there's no equals there, so it's not a solid line. So now, same line, one shaded this way, one shaded that way. Less than. Well, if you look and you can tell what's less than, then you could choose pretty easily, but if not, let's test a point. Okay, let me show you an example. So let's do 0, 0. If I plug 0, 0 into this, I would get 0 is less than 2, right? Because that would go away. 0 is less than 2. Is that a true statement? It is. And so I would shade the side with 0, 0, and it is this graph right here, which happens to be below. Sometimes, again, it's hard maybe to say, is that below or is it, but yeah, below, and so that one works. How about this guy? The graph is a solution of which inequality? So it's solid, so automatically I cross out that guy and that guy, right? It looks like it's above to me, and so I'm liking that one. Again, if I test a point though, just to show you, 0, 0, what if I go plug that in? I would get 0 greater than or equal to 2. Hey, that's not true, and this one is it. So I would shade the opposite side. Hopefully that's making sense. Okay, how about this guy? Which absolute value inequality? Now, absolute value just combines a couple lines, and we've been working with graphs of absolute values. Which absolute value represents this graph? Again, they've got similar characteristics, so they're not trying to trick me here, but it's dotted, so that means it can't be equals, right? So get rid of that. It's above, and so it looks like this is a possibility, this is a possibility. Get rid of that one. Now let's see what the difference is. They have a negative in front of this. Well, remember what a negative would do to your absolute value graph? It would flip it upside down. And so get rid of that one as well. Hey, C looks like a winner there. Which describes the situation or the solution? Okay, greater than absolute value negative 3x. Well, greater than, is that going to be dashed or solid? Well, it's a dashed line, isn't it? And it's greater, so is it going to be above or below? Well, it's going to be above. So shaded above the dashed boundary. Hey, I like that one right off. Shaded below, nope. Shaded above the solid, nope, not solid. Shaded below the dash, no, not below. See what we're doing there? Okay, one more. Two variable graph shows which. Okay, so what graph are we looking at here? Again, they've given us pretty similar characteristics, but we better look at it. So this one went to the right 2. So if we just kind of reviewed our previous lesson, it's upside down, by the way, so it's going to have a negative out front. It went to the right 2, so that's going to look like x minus 2. That's the one the sign feels backwards. And up 2, so plus 2. So there would be the actual equation. Now it's dashed, though, and it's below it. So dashed and below. So let's see. Negative, that one doesn't work. We already got rid of those two, right? Because this matches our equation. So it's below it. I like that one. And it's dashed hey, C looks like a winner. Can't be this one. Can you tell why? Because of the equal sign. It would have to be a solid line if it were that way. Okay, there you go. Again, I know it's kind of quick, but this ought to be review for you, and that ought to help you go through and do well in the lesson, I hope.